MathGenie.
In this video, I'll be explaining how to solve complex divisibility problems for number 11. In the pinned comment section down below, I'm going to be putting a link to the other two previous videos that I already posted about divisibility rules for number 11. So I highly recommend you to watch those two videos before watching this video, because watching those other two videos will help you enhance your understanding for this type of problems. So be sure to check those out before watching this one. So let's look at the question. Find the remainder when 1,234,567 is divided by 11. So as some recap, in my previous video, I already talked about the divisibility rule for number 11. So what is the divisibility rule for number 11? Well, you have to find the sum of the alternating digits and subtract those two sums, and the result should be either a 0 or it should be divisible by 11. So you'll find more detailed explanation for this rule in my previous videos. So again, I'll link them down below. So be sure to check them out. So how do you solve this problem? Well, you might be tempted to go ahead and divide the 7-digit number by the 2-digit number 11. Well, you can do that, but again, that will be a little bit time consuming. So what I'm going to be doing to solve this problem is to use that divisibility rule so I can take a shortcut when I'm solving this problem. So again, the rule states that I have to first find the sum of the alternating digits. So if I basically write out this number again, let me do that. So it's just the 7-digit number when you write it out. Well, the alternating digits will be, well, the first set of digits is going to be 1, 3, 5, 7. And the other set of numbers, which I'll do it in pink, is 2, 4, and 6. So the rule is stating is that when I add the yellow numbers and subtract them with the pink numbers, then the result should be either a 0 or divisible by 11 if this number, the 7-digit number, is divisible by 11. So let's go ahead and do that. So let's first add up all of the yellow numbers. So that will be 1 plus 3 plus 5 plus 7. And the rule tells me to subtract that. And I have to add all the pink numbers up. So it'll be 2, 4, and 6. So if I solve this, we'll see what the result is going to be. 1 plus 3 equals 4, 4 plus 5 equals 9, and 9 plus 7 gives me 17. And let's subtract that. 2 plus 4 equals 6, and 6 plus 6 gives us 12. Oops, my bad. That should actually become 16 here. Alright, so you have this simple equation here, and let's see what the answer is going to be. And the answer is obviously a 4. But let's look at this. Well, what this is basically telling us is that this number that we're given with is definitely not going to be divisible by 11, which means that the number that we're given with is not going to be having a remainder of 0. Since, again, it's not divisible by 11. So this is basically telling us that we're 4 digits away from the actual number that is divisible by 11. So for instance, if we, for example, had a number like 1,234,563, which is exactly 4 digits away from this number here, since we just changed up the 1's digit, so this number is 4 digits away from 1,234,567. Well, if we actually add up all the alternating digits and subtract it, we're actually going to get the answer of 0. So we just figured out that this number here, which I will highlight with green, is actually divisible by 11. So since this number here is actually 4 digits away from a number that is divisible by 11, we can automatically see that this number here that we're given with is going to be indicating the remainder, right? So the answer to this question is going to be 4. So whenever you actually have a number that you need to find, and if it's divisible by 11, well, what you just need to do is you just need to use the rule to find the sum of the alternating digits, subtract them, and whatever answer you get should actually indicate the answer. So this should be the answer. So without even having to find the number that's closest and make sure it's divisible by 11 like I did over here, which I'll indicate as step 2. Since this is an optional step, you don't really need to do this step because you already get your answer in step number 1. So that's it for this video, and I'll bring back my final problem, so the final divisibility problem for number 11 next week in my next video. Thank you for staying to the end of this video.
Math Genie.